Chapter 1, Reflection of Light at Curved Surfaces. Topic 1.8, Ray Diagrams for Convex Mirror. We have three rules describing the ray diagrams for convex mirror. In rule 1, ray 1 always travels parallel to the principal axis. In rule 2, the ray 2 always travels towards the focus. In rule 3, the ray always travels towards the center of curvature. Let us discuss in detail. Now, rule 1. Here, the ray 1 always travels parallel to the principal axis, and after reflection, it appears as if it is starting from the focus. See here, the ray is traveling parallel to the principal axis. The ray is traveling parallel to the principal axis and it meets convex mirror. The ray meets the convex mirror, and after reflection, the ray appears as if it is starting from the focus. After reflection, the ray appears as if it is traveling from the focus. Coming to rule 2. In rule 2, we will discuss about ray 2. The ray 2 appears traveling towards the focus, and meets the convex mirror. After reflection, the ray travels parallel to the principal axis. After reflection, the ray travels parallel to the principal axis. Let us discuss about rule 3. In rule 3, we will discuss about the behavior of ray 3. Now, the ray 3 appears traveling towards the center of curvature. Ray 3 appears as if it is traveling towards the center of curvature and meets the convex mirror. After reflection, the ray appears as if it is starting from the center of curvature. These three rules are useful to describe the ray diagrams for convex mirror. We have two ray diagrams for convex mirror. In the first ray diagram, the object is kept at infinity. The object is kept at infinite distance. Now, when the object is at infinite distance, the light rays travel parallelly. Now, the parallel light rays move like this and they fall on the convex mirror. Now, when they fall on the convex mirror, they get reflected. The reflected rays meet at a point and we get image. The image is point size and highly diminished, erect and virtual. Now coming to the second ray diagram. In this case, the object is kept at in front of the pole, or else we can also keep the object at any place between the infinity and the pole of the mirror. Now here, when the ray 1 starts from the source of the object and it travels and meets on the convex mirror, it reflects. The reflected ray appears as if it is starting from the focus. Then the third type of ray, it starts from the source of the light and it falls on the convex mirror and it appears as if it is starting from the center of curvature. These two reflected rays meet at a point, and at the point of intersection we get the image, and the image is formed at focus and the image is diminished and erect and virtual. Convex mirrors are used as rear view mirrors. We can see that when we are moving on a vehicle in a car or a scooter or a bike or two-wheeler, then we might have observed. Now when we are moving on these vehicles, when we want to see the vehicles coming from backside, now we look into the rear view mirror kept in front of our vehicle. That is, from the rear view mirror we see the image of the objects coming from the backside of our vehicle. Now when the vehicle coming from backside of the vehicle, backside of our vehicle is at very far distance, that the objects or the vehicles appear very small. Now when the backside vehicles are moving towards us, then the size of the vehicles becomes bigger and the image appears bigger. Now that means the object distance, when it is decreased, the size of the image is increasing. This relation I want to explain here. See here, the object distance and the image size. Now here this is the rear view mirror. If you consider this, then when the object or the vehicle is at a far place, then the size of the image is smaller. Now when the vehicle is moving towards the mirror or towards our vehicle, now when the object is moving towards the mirror, then we can say the size of the image is increasing. That means here, when object moves towards the pole or the mirror, we will observe that image also moves towards the mirror.